Can you hear me?
Hello.
Yeah. Can both of you hear me?
Yes.
Okay. So when are your A levels exams?
In June, I think.
For Noah, when is it?
Yes, it's in June.
And for Adam, you also have these exams, right?
Yes.
Around the same time for both of you.
Yes.
And both of you are taking the pure maths course.
Yeah. Yes.
Okay. So how is your prep right now for pure maths? How's it going?
It's going all right.
All right. Uh, Tell me, what are the topics that you guys are finding difficult? Any of you, like Noah or Adam, either of you. If you're finding some particular chapter difficult, you need to tell me. Like, as far as I know, the chapters in pure maths are algebra and functions. Is that there?
Uh, I think there is quadratic.
Is there quadratics comes inside that? Algebra and
Yeah.
functions. The
Yeah.
transformation of functions and quadratics and polynomials, all of it is in here.
Yeah.
Inequalities.
Yeah.
So the second topic is uh, coordinate geometry is there, right?
Yes.
Coordinate geometry. And then we have binomial expansion. Is that there for you guys?
Yes.
Differentiation, integration,
Yeah, that's also there.
trigonometry,
Yes.
exponentials and logarithms.
No.
Noah, is it there for you?
Uh, I don't think it's in you are in pure maths one.
Exponentials and logarithms you are saying is not there.
Yeah, I don't think it's
Uh,
exponential.
Vectors, what about vectors? Vectors is not in the
there's also
syllabus.
that's also not in the syllabus for pure maths one. I think the syllabus for pure maths one it says here is quadratics,
Hmm.
functions, coordinate geometry,
Hmm.
circular measure, trigonometry,
One
series and
second.
patterns.
Hold on for a
Okay,
second. Quadratics, functions,
functions,
then
coordinate geometry,
okay,
circular measure,
basically trigonometry.
trigonometry,
Hmm.
then series,
Okay,
uh, then integration and differentiation.
integration, differentiation. And if you go into the series topic, what is there in series? Go into the details of series.
So,
What is there?
uh, let me check. It says
AP, GP,
arithmetic progression, geometric progression.
Hmm.
Uh, yeah, that's basically it. Arithmetic and geometric progressions.
Okay, fine. So, how much has been covered in school so far here?
Um, at school we've done it all.
Okay,
Okay.
so you are comfortable with all of it. Which chapters
Um,
need most help? What is the stuff that you find the most difficult?
probably So let me see, out of those series, I'm not the best with.
Mhm. What about
Uh,
differentiation and integration?
I think I'm not too bad with it. Like,
Okay, so series,
yeah.
differentiation, integration. What about you, Noah? What is your situation?
Uh, I think for me the hardest um would probably be Jakob Revised series, and then
Hmm.
uh
Hmm.
maybe also revising functions, so like the graphs of functions.
Right. So for Noah, your exam is at a higher level, right? You are
Well,
doing
I like
Noah's exam is at A levels, right?
so I'm writing yeah.
Tell me, you have to finish your sentence.
Yes, the exam for me will be at a high level.
For Adam, it will be easier, right?
Yes.
Okay, so fine. What is the difference? Noah, you are writing it at what level?
I'm writing A levels, but I'm saying AS.
Okay, fine. So we'll start off with series and we'll start off with this and then we'll go back to other topics as and when required. So first of all, let's think of series and we want to understand two different types of series, AP, GP. And if necessary, we can also discuss harmonic progression. Has this been taught, harmonic progressions?
No.
Okay. So first two things that we want to talk about here are arithmetic progressions and geometric progressions. So it's very simple. Arithmetic progressions are basically sequence of numbers where the difference between any two is constant. The difference between two successive numbers. Difference between two successive numbers is constant. What does that mean? You have to have numbers like this 2, 4, 6, 8, 10. This is an arithmetic progression because the difference between these is always 2, right?
Yes.
Yes.
So in general, you can write it like this: A plus D, A plus 2D, A plus 3D, and so on till A plus, let's say, N minus 1 into D. So this is becoming our first term of the AP. This is the second term. This is the third term. And this is term number. What is the term here?
N.
This is the nth term, right? So notice that in the nth term, you have n minus 1 times d. In the second term, you had 1d. In the third term, you had 2d, right?
Yes.
Yes.
So this d is your common difference. The name itself tells you what the meaning of d is. It's the difference between two successive terms, but in case of an arithmetic progression, that difference is always same, right?
Yes.
So therefore it is called common difference. Common difference basically because it is equal to Tn minus Tn minus 1 or T3 minus T2 or T4 minus T3 or whatever, right?
Yeah.
Now, once you learn how to identify an arithmetic progression, the second thing that you need to know is the sum to n terms. This symbol stands for sum to n terms of an AP. We are trying to find that. So if you want to find the sum to n terms of an AP, we can start by listing out the terms and writing it like this: a plus d plus a plus 2d and so on. What is the nth term? A plus n minus 1 into d, right?
Yes. Yes.
Sn is equal to this, and in order to quickly find the sum, there is a nice trick where you write the same Sn, but this time you start with the last term. So basically we'll reverse the order of the series, right?
Yeah.
Because the sum should not change its value just because you reverse the order, right?
Yeah. And then
So,
you just add, right?
right, so we are writing the last term first, and the second last term is this, and so on. And the first term will come at the end here, right?
Yes.
So when you add these two equations, you get twice of Sn is equal to, if you notice, you will add this and this, you will get 2a plus n minus 1 into d. And when you add this and this, again you get the same thing. Can you see that?
Yes.
Basically, every time you add, you get the same thing.
Yeah.
So how many pairs are there? There will be n pairs, right?
Yes.
So we'll say you have to add the same thing n times. So it is n times 2a plus n minus 1 into d. And that is equal to 2Sn. So you get Sn is equal to n by 2, 2a plus n minus 1 into d, right?
Yeah.
And this can be thought of as n by 2, a plus n minus 1 d. And you can think of it as n by 2, first term plus last term.
Oh.
This is the last term, nth term. This is the first term. So the sum of the AP from n terms is equal to n by 2 times first term plus last term.
Yeah, I see.
You have to remember this, and you can also think of it like this to easily remember it. Is it clear?
Yeah. Yes.
So that is the basic idea of an AP. Now let's think of GP. What is a geometric progression? This is slightly different. Here the terms are multiplied, right?
Yes.
So this is my first term T1, this is T2, this is T3, and Tn will be AR power n minus 1. So every term is obtained by multiplying R with the previous term, right?
Yes.
So we can say R is equal to T2 by T1 is equal to T3 by T2 is equal to T4 by T3 and so on. It is equal to Tn by Tn minus 1. So it is called the common ratio
Yes.
because clearly you can see that the ratio of all the terms is always same, right?
Yes.
So now if you want to find out the sum of first n terms of a GP, you have to do this sum, correct?
Yes.
How do we do sum of these n terms of a GP? First of all, we'll again use a nice trick. What we will do is multiply this equation with R, okay?
Oh, okay.
So first I will write it like this. Sn is
Oh,
this. These are my terms, a r power n minus 2 and a r power n minus 1. Now I'll multiply both sides of this equation by r, okay?
yes.
So what should be the first term here? AR, right?
Yes.
But I will not write it beneath the A here. I will write it beneath this. So I'll start from here. AR. The second
Uh,
term should be what? AR squared, right?
yes.
And so on. The second last term would come when I multiply R with this. It will become AR n minus 1. And the last term will be AR power n, right?
Yes.
I have done nothing. I have just written it like this and shifted it one step.
Yeah.
The benefit is that if I subtract now, so many terms will get cancelled. Can you see?
Yes.
All of these will get cancelled because they are matching, right?
Yes.
So this will become negative and this will be positive, and you will get Sn 1 minus r is equal to a minus ar power n.
Yeah.
And therefore, Sn is equal to a common 1 minus r power n divided by 1 minus r.
Yes, I see.
So the point is not just to remember the results, the point is that you need to know how it has come.
Yeah.
These are pretty simple things, but you need to know how to do it, like how to get the formula. Don't
Yes.
think that it is enough to just remember the answer. Okay.
Yes.
Also, one special case is if you keep taking terms till infinity, n tending towards infinity. So basically, I want the sum of the geometric series, but the number of terms is becoming really large. Okay.
Yeah.
So obviously, if your common ratio r is bigger than 1, if r is bigger than 1, then the sum will tend towards infinity, right?
Yes.
Because if r is bigger than 1, then the second number is bigger than the first, the third number is bigger than the second. So the sum will become really large, right?
Yeah.
Because you have infinite terms, you will have to add infinitely large things and it will never be small, right?
Yeah.
However, if r is less than 1, in that case, you should realize that the values of the terms will become smaller and smaller, right?
Yeah.
And the overall sum is not going to go very big because the terms that you are adding is becoming really tiny, right?
Yeah.
So in that case, what you can say is, what is the sum to where n tends to infinity of this series, where r is less than 1, the common ratio is less than 1. In that case, we can take this formula for the sum that we had found. This was sum of n terms. We are doing limit of n tends to infinity of Sn, right?
Yeah.
Now, if you have done a little bit of calculus, the terminology here should not be surprising. It is the limiting value of the Sn term, right?
Oh, okay.
As Sn, as the value of n becomes really large, what is the value of this, right?
That becomes
So I want you to understand what the limit concept means. Everybody is aware of that?
I've heard of it.
Right. Noah, you know what it is, right?
Yeah. So
In this
like
expression,
basically as
right, as n tends to infinity, this expression will become something, right?
Yeah.
So that is what we are saying is the limit of Sn as n tends to infinity. So
Oh,
think about it. If r is less than 1 and you are raising r to the power n where n is becoming really large, what will happen to a fraction when you raise it to a very high power?
it will become very small.
Right. So it should become very small. So as n tends to infinity, r power n will tend to 0, right?
Yeah.
So the formula will become a into 1 minus something tending to 0 by 1 minus r, right?
Oh, yes, I see.
This becomes a by 1 minus r, which you might have seen already.
Yeah, I think I've seen that.
Sum to infinite number of terms is a by 1 minus r, and it has come from the sum to n terms formula, but n is tending to infinity and r is less than 1. Only if r is less than 1 can we say that r power n will tend to 0 as n tends to infinity.
Yeah.
If r was equal to 1 or more than 1, it will not tend to 0 then.
Yeah.
So that gives you your GP formula. Now, one type of series that I don't know whether you guys have seen or not, but I want you to figure it out. Find the sum of this series. 1 by 2 plus 3 by 2 square plus 5 by 2 cube plus 7 by 2 power 4 till n terms. You have to find an expression for Sn where you can clearly see the first 4 terms of the series. Anybody
Yes.
having any idea? Let me know what you think about it. Noah, you were saying something?
Well, you can see that the denominator is being multiplied by a half each time. So it's probably a geometric series.
Right. But it is not exactly a geometric series, right?
Yeah.
That's because of the numerator. So you should notice the pattern that the numerator is at AP,
Yes.
but the denominator is like a GP.
Yeah.
So the combination is a combination of both of them, right?
Yes.
Because no matter what you do, you cannot say that this series is an AP because the difference between this and this is not the same as the difference between this and this. You can check it out. 3 by 4 minus 1 by 2 is 1 by 4, but 5 by 8 minus 3 by 4 is actually going to be minus 1 by 8, right?
Yes.
So nobody can say that it's an AP, right?
Yeah.
Similarly, it is not a GP because 3 by 2 squared divided by 1 by 2 is basically 3 by 4 by 1 by 2, which is 3 by 2, the ratio of this term and this term. But the ratio of the third term and the second term is 5 by 8 divided by 3 by 4, which is actually 5 by 6. So the ratio is also not matching, right?
Yeah.
Yeah.
So sometimes you will get a problem like this, which usually this type of series is called a arithmetic geometric series. It's given a name, it's called AGP.
Oh.
Because parts of it are AP, parts of it are GP, right?
Yeah.
Yes.
This is an AGP, and this is a type of question that you might see. I don't know if you have seen it so far, but definitely you'll see it at some point when you are learning. So what should we do here? So pay attention to the process that I'm telling you. The process is important so that you can replicate the process. Nobody can remember the formula for it. For
Oh.
example, we have learned formulas for sum of an AP and sum of a GP. Nobody expects you to learn the formula for sum of AGP. Okay.
Okay.
But you are supposed to know how to handle it. Okay. So
Yeah.
what I will do is do a general case. So let's say the terms for me are A plus D R, A plus 2D R square, A plus 3D R cube. This is the situation. And the nth term will be A plus n minus 1 D R power n minus 1. Right?
Yeah.
This is what we have to add, right? Notice that parts of it are AP, parts of it are GP.
Yes.
Yeah.
So the method is, again, what we will do is we will multiply by the common ratio R of the GP, and we will subtract this, but only after shifting it a little bit. Same method like GP.
Yeah.
So if I multiply each term by R, first term should be AR, right?
Yes.
But I will not write it under A, I'll write it under here. Okay?
Yeah.
Second term would be what? A plus D into R square.
Yeah.
Third term would be A plus 2D into R cube. Do you understand what I'm writing here right now?
Yes.
Yes.
I'm multiplying this, all of these terms with R, and I'm writing it down, but I'm writing it beneath this and beneath this and so on, right?
Yes.
The second last term would be A plus n minus 2D into r power n minus 1, and the last term would be a plus n minus 1 d into r power n. I hope you have understood what I've done.
Yes.
Yes.
Okay, so now I'll subtract the two series. So I'll say Sn 1 minus r is equal to, there is nothing to subtract between these two, so that will remain. But when you subtract these two, AR will get cancelled, right?
Yeah.
And what
Yeah.
will be left? DR, right?
Yes.
When you subtract this and this, notice that only dr square will be remaining,
Yes.
correct?
Yes.
Similarly, when you subtract this and this, what will be remaining?
Uh,
D.
dr cube, right?
Yeah.
yes.
And then when you subtract this term from the last term here, what will be remaining is d r power n minus 1, right?
Yes.
But you still have to subtract this. So we'll write it like this, minus a plus n minus 1 d r power n, right?
Yeah.
See, I had shifted the terms here by one step. No, that's why I'm getting a negative term here for this, right?
Yeah.
Yeah.
And the first term of this was untouched. It was brought down directly, right?
Yeah.
So now notice that here I can write a minus a plus n minus 1 d r power n plus, and now I have a series here that's a very simple series to sum.
Yes.
Can you see that it's a direct GP?
Yes.
Adam, are you understanding that this is a GP?
Yes.
This is a GP whose first term is dr, common ratio is r, and number of terms is basically power goes from 1 to n minus 1 terms are there, right?
Yeah.
Okay, so I will create some space here and we'll write the expression as we figure it out. So what it becomes is Sn 1 minus r is equal to a minus a plus n minus 1 d r power n plus first term is dr. So in the GP formula, I'll write dr for a. Common ratio is r between them. So 1 minus r power. How many terms are there? N minus 1,
Yes.
right?
Yes.
So it will be n minus 1 divided by 1 minus r, right?
Yes.
Yeah.
And then your expression comes for Sn. Sn is a by 1 minus r minus a plus n minus 1 d r power n by 1 minus r plus d r 1 minus r power n minus 1 by 1 minus r whole square.
Yes.
Correct? Notice
Yeah.
that nobody is asking you to remember this. There's no point of trying also. However, what you need to know is the process by which we got here. So now I need you to find the answer for the question that I asked. 1 plus 3 by 2 plus 5 by 2 square plus 7 by 2 cube till n terms.
Okay.
If you have understood the process, you should be able to find this sum.
Okay.
Try it out.
No.
Any progress?
Yeah.
If you follow the method, you will get it.
Damn. Okay, I got an answer. Oh wait,
Okay.
no, wait. One more step.
See, You should think of the nth term first. So
Yeah,
what is the nth term going to look like?
I got it as 2n minus 1 over 2 to the power of n minus 1.
So 3n minus 2n minus 1, right?
Yes, yes,
So 2n minus 1 divided by 2 to the power n minus 1, right?
yes,
Great. So now this, if you know, then you can write it like this: Sn is equal to 1 plus 3 by 2 plus 5 by 2 squared, so on till 2n minus 1. So the previous term would have been this, right?
2 minus 3. Yes,
You realize the term before that would have been 2n minus 3.
yes,
So now I have written the last two terms because I will follow the same method. What is the common ratio of the GP? It is half, right?
yes,
So I'll multiply this with half, correct?
yes,
And I will write all the terms, but I'll shift it one step. So 1 into half, I'll write half here. Plus 3 by 2 square. Plus 5 by 2
yeah,
cube. And so on. I will
yes,
get a 2n minus 3 by 2 power n minus 1 here and 2n minus 1 by 2 power n here, right?
yes,
So when you subtract these two now, you will get Sn by 2. Sn minus Sn by 2 is Sn by 2 only, right?
yes,
That is 1 plus. Now take the difference of these terms. This is 1 plus. Notice the difference is 2 by 2 square, right? Plus, then the difference is 2 by 2 cube because this term would have been 7 by 2 cube, right?
yes,
And therefore the difference is always 2, and this term would be 2 by 2 power n minus 1, right?
yes,
Minus 2n minus 1 by 2 power n, right?
yes,
So notice that this series in the middle, we can do the sum of it on our own. We can write it as 1 plus half plus 1 by 2 square, so on till 1 by 2 power n minus 2, right?
yes,
This is what? This is a GP, right?
yes, yes,
GP with first term is 1, common ratio is half, and number of terms is n minus 1.
yes,
So the sum of this GP will be 1 minus 1 by 2 to the power n minus 1 divided by 1 minus half, right?
yes,
So this becomes half here in the denominator. So 2 goes on top. You get 2 into 1 minus 1 by 2 power n minus 1, right?
yes,
So we have gotten Sn by 2 is equal to 1 plus 2 into 1 minus 1 by 2 power n minus 1 minus 2n minus 1 by 2 power n, right?
yes,
And then you multiply whole thing by 2 and that will be your answer.
yeah,
Do you understand what I have said?
yes,
Okay, so now solve these two questions. Question 2 is this: the second, third, and fourth terms, second, third, and fourth terms of an AP are 3k, 4k plus 5, and 7k. 3k, 4k plus 5, and 7k, where k is a constant. Show that the sum of first n terms of this AP is equal to kn square, where k is a rational number.
right,
K is a rational number.
and the sum of interns. This is not good. Oh, first plus the last times the first plus the last comes to 2. So it's 1 over 2 times first last and the last. The last term is the nth term. The nth term is it's 2 and
You don't know the last term, so right now you don't know the last term.
yeah,
But because there are successive terms that are given, what can you do? You can find the common difference, right?
yes, and
What is the
10.
common difference?
The common difference is 10.
It is first you will subtract these two, you will get k plus 5, right?
Yes,
And then you can subtract these two, you are getting 3k minus 5, right?
yes,
So both must be same, no?
yes,
So from there you can say 2k is equal to 10, so k is equal to 5.
yeah,
And therefore the terms are what? 15.
uh,
This is the second term, by the way, right?
yes,
What is the third term? 25
yes,
and 35. So common difference is 10, right?
yes,
What will be the first term?
5,
5. So this is my sequence, and sum of first n terms is being asked, right?
yes,
So formula for sum of first n terms is n by 2, first term plus last term, right?
yes,
So first term is 5, last term would be, last term is nth term. Nth term is always a plus n minus 1 into d, right?
yes,
This is Tn, no?
yes,
So this will be 5 plus n minus 1 into 10.
yes,
So you'll say 5 plus n minus 1 into 10 here, right?
yes,
So we are getting what? 10n minus 10, and 10 gets cancelled.
oh, yes,
So then you're getting what? You're getting 5n square.
Yeah.
yes,
Clearly k is a rational number, 5 is a rational number.
yes,
The point is you have to use this information to find the common difference and the series.
The
yeah,
way I did it is I just said that a plus d equals to 3k, a plus 2d equals to 4k plus 5, and then a plus 3d equals to 7k. Then I solve simultaneously to solve for a, d, and k. And that's how I got k equals 5. And then from there, I got the formula.
That's fine. It's the same thing what we have done. There's no difference. We also
Okay.
did this minus this is equal to this minus this. The equations that you are saying are equivalent to what I am saying. No,
Yes.
ultimately the common difference has to be common. So common difference between these two has to be equal to these two, right? And from there you can get k is
Yeah.
equal to 5 immediately. And once you get k is equal to 5, you know the three second, third, and fourth term. So you can also figure out first term. You can also figure out nth term and so on. Right?
Yes.
Yes.
Okay. Next question is 1 second. A geometric series has first term 20 and common ratio 4 by 5. First term 20 and common ratio equals 4 by 5. Given that the sum of terms, given that the sum of k terms is greater than 50, you have to first of all show that k is greater than ln. ln means natural logarithms. ln 0.5 divided by ln 0.8, and b, you have to show that you have to find the smallest possible value of k.
Okay.
So everything about the series has been given to you. Common ratio, first term, even the sum to k terms, they have said that is greater than 50. You have to think of how to find k basically.
Yeah.
I hope the question is clear.
Yes, it is.
Sum to k terms of this geometric series can be written as 20 1 minus 4 by 5 to the power k divided by 1 minus 4 by 5, right?
Yes.
Okay, so 1 minus 4 by 5 is actually 1 by 5. So if you simplify it, 20 divided by 1 by 5 will be 100.
Yeah.
So you will end up with something like this. This is the sum to k terms, right?
Yes.
The question has said what? It is greater than 50. So we can say 100 into 1 minus 4 by 5 to the power k is greater than 50.
Yes.
So what can we do now? We can divide by 100 and all. We can say 1 minus 4 by 5 to the power k is greater than half, right?
Yes.
So we can say half is greater than 4 by 5 to the power k, right?
Yes. Yes.
And now what?
Um.
We have to think of isolating k. The only way to do that is to take logarithms,
Oh, yes.
because otherwise you'll not be able to do that power thing, no? How do you remove the power, right?
You can't.
So what you can say is you can do half to the power k is greater than 4 by 5, right?
Yeah.
So, or instead of that, I will do it like this. Half is greater than 4 by 5 to the power k. Now, think of the properties of logarithms. Log x is greater than log y, or if we are talking about natural logarithms, ln x is greater than ln y implies x is greater than y. Do you know this?
Oh, yeah.
This is true because the base of the logarithm is what? E, right?
Oh,
Do you know what E is?
isn't it that number where e to the e squared is equal to e?
No. E
Oh,
square is never equal to E. E is the number 2.71828. E is a special number such that if you have a function like e power x, the derivative is same as e power x.
oh, yes.
Noah, do you know all this?
Yes.
So the base of the logarithm is the irrational number e, and in that case, because the base of the logarithm e is greater than 1, therefore we can say ln x greater than ln y means x greater than y. Because
Yeah.
e is greater than 1.
Yes.
If the base of the logarithm was less than 1, if e was less than 1, the inequality would be reversed.
Oh, yeah.
So ln x greater than ln y would mean x is less than y if the base of the logarithm was less than 1.
Yeah.
Do you understand what I'm saying? So
Yeah.
here, what I can say is because this is bigger than this, log of this is also going to be bigger than this, right?
Oh, yes. Yes, yes, yes.
To the base e, because the base is bigger than 1, there is no need to tamper with the inequality. You can take log on both sides.
Yeah.
If you are taking log to a base of something less than 1, then you would reverse the inequality. Do you understand?
Yes.
So you have log half is greater than, property of logarithm is k can be brought down. K times log 4 by 5. Correct?
Yeah.
And
Yeah.
now you can say k is less than log. Okay, 1 second. Now, this part is important. Has everyone understood what I have said so far?
Yeah.
Yes.
Yes.
Okay, because there is a tricky part here. If you don't get it, then you will not understand. The part here is to realize that, tell me whether this is positive or negative, both of these logs.
Uh,
Log half and log 4 by 5. Are they positive or negative?
they are negative.
Noah, Adam, do you understand?
Uh,
They have
what?
to be negative because they're less than 10.
No, they have to be negative because they are less than 1. Because
Oh,
right now
sorry, less than 1. Yeah.
when I'm writing log, I'm writing base e always, okay?
Oh, yeah.
Now think about it, Adam, if you have not understood, see, if you have e raised to the power x is equal to y, right?
Yeah.
Suppose you have this situation, but e is 2.718 and all, something like that. So how can
Yeah.
I raise e to the power something and get a value less than 1? Is it possible for positive x?
Only if the
It is not possible for positive x, right?
yeah.
If you take log right now, log e power x is equal to log y, and you will get x log e is 1 is equal to log y. So right now, x is basically log base ey. This statement means the same thing as this statement. Both of them are the same thing written in two different ways, right?
Yes.
Now, the only way to get x, or the only way to get y to become less than 1, how can you raise 2.7 to some power and make it less than 1? X has to be negative.
Only if yeah. Wait, if why can't x be a fraction?
If it is a fraction, it will still be bigger than 1. For example, 2.718, if you raise it to the fraction 1 by 2 or 1 by 10, even if you take 10th root of it, it will still be bigger than 1.
Oh, okay.
Think about it.
Yes, yes.
If you take a number 1.1 and keep raising it to many powers, then it will become larger and larger, however large you want to make it, right?
Yes.
Whatever power you put here, you cannot make it less than 1 unless the power is negative. Because the power of 2.718 to the power 0 is 1. Right?
Yeah.
So
Yes.
basically, because I have fractions inside my log and my base is bigger than 1, and these two numbers are less than 1. So the values of the logs are positive or negative?
Negative.
So they are negative values. So right now, I have this is a negative quantity is greater than this, right? Correct?
Yes.
So if I want
Yes.
to isolate k, I want to solve the inequality for k, right?
Yes.
The normal thing to do would be to divide, right? By log 4 by 5.
Oh, yeah.
But if you divide, it is a negative thing you are dividing by, right?
Yes.
So
Yes.
inequality has to be done what?
Reversed.
Right. So it will be not like this, it will be like this, right?
Yes.
Do you understand what I'm saying?
Yes.
So you'll have to say k is greater than ln half by ln 0.8, right?
Yeah.
If you don't reverse the inequality, you will get something wrong. Because actually you are dividing by a negative number, right?
Yeah.
So the main thing in the problem is not the GP part. The main thing is to understand logarithms and be able to simplify.
Yeah.
The GP part of it was pretty easy actually.
Yeah.
Is everyone following what I'm saying?
Yes.
Yes.
Now find the smallest possible value of k. We know that k is greater than ln 0.5 by ln 0.8. But k has to be an integer, right?
Yes.
So notice that both of these are negative. So eventually this quantity is a positive number, right?
Yeah.
Yes.
So it's about figuring out an approximate value of this fraction, correct?
Yes.
Yes.
So, okay, so let's think about it. So it will be basically ln half. So ln half can be written as negative ln 2 by ln 4 minus ln 5, right? Because I'm writing it as ln half, which is ln 1 minus ln 2.
Yeah.
ln 1
Oh.
is 0.
Oh, 0. Okay.
So this becomes negative ln 2 by 2 ln 2 minus ln 5, right?
Yes.
Yeah.
Now think about it. ln 2 and ln 5. So log of base e, and you have 2 here. Roughly, let's think about the power that is required. 2.7 to the power x is equal to 2, right?
Yeah.
Yes.
So, if you think of square roots, the square root close to 2.7 is 2.56 square root is 1.6, right? And 2.89 square root is 1.7. 1.7 square is 2.89, right?
Oh, yeah. Yes.
So I need a number close to 2 should come when I do power of 2.7. So if I had x was half, then I would have gotten something close to 1.7, something less than 1.68 or something, right? If x was
Yeah.
half.
Yeah.
So you can imagine sort of the power, or maybe I don't know whether calculators are allowed or not. I'm assuming calculators are, if they are not allowed, you'll have to do all this. If they are allowed, then you can
They're all
just,
allowed.
if they are allowed,
They're
you
all
just
allowed.
calculate the answer, right?
Yeah.
So let's not waste time on it now. The point is you should
Okay.
use the calculator and get the answer at this stage.
Yeah.
Do you guys know what is sigma notation?
Yes. It's the sum. Wait, Adam, do you know?
No.
Adam, you don't know?
This is
So sigma notation is a notation like this where r goes from, let's say, 1 to n, and you have tr. What this means is the r values keep increasing from 1 to n, and you keep adding all the terms. So this notation basically means t1 plus t2 plus t3 and so on till tn.
Okay.
So you are basically adding up this every time r changes, you write one term, one term, one term, and so on, right?
Oh,
So
okay.
basically, it's a shortcut way of writing so many terms. I will write it as tr, and r goes from 1 to n, right?
Yeah.
And the sigma here tells us that it means you have to keep adding them.
Yes.
So when I write the sum of a AP, I can write it like this. Earlier we have learned it is a plus d plus a plus n minus 1d is equal to, we learned this formula, right?
Yes.
yes.
What we can say in sigma notation, we can write it like this: sum of a plus r minus 1 into d, where r goes from 1 to n.
Oh,
Notice here, when r is 1, what do you get? You get the first term.
yeah.
When r is 2, what do you get? You get second term.
Yeah.
And similarly, when you get r is n, you will get this term. Right?
Wait, when all is one.
Mm.
Oh, yeah. Yeah.
When r is 1, you will get this. Then plus, when r is 2, you will get this, and so on, right?
Yeah.
So we are writing one general term and writing the sigma notation, and this means the same thing as saying sum of this series.
Yes.
So this will be equal to n by 2, 2a plus n minus 1 into d.
Yes.
Similarly, for GP also you can write in sigma notation form. And what we will do is understand, for example, a couple of questions we can see. So one question is this: given that the summation of r goes from 1 to k, summation r goes from 1 to k, tr plus 6 is equal to 750, you have to find the possible values of k. Find the possible values of k. So not a very difficult question, just try it out.
Okay. And then this form.
If you are confused, just write down a few terms and you will see what is happening.
Yeah, so it's a arithmetic progression. Okay. Comes terms. Let's say that's the case term. And some the case term is k of 2 times 9 plus.
One property of sigma notation that you can remember is if you have a situation like this, you can always separate it out into two separate sigmas.
Oh,
There is no difference between writing it separately
oh yes, I see.
because ultimately you'll have to add b1 to bn here and a1 to an here, right?
Yes,
You can either combine it or you can separate it also. So here, if you think about it, you can write it like this. R goes from 1 to k, 3r plus r goes from 1 to k, 6, right?
yeah,
And then another property of sigma notation is if you have a situation like this, 3r, right? You can always take 3 as a constant. It can be brought outside the summation.
oh.
Why? Because think about it.
You're just telling the whole thing back to me.
So technically this series is what? 3 into 1 plus 3 into 2 plus 3 into n, right?
Yeah,
And what is this series? 3 common, 1 plus 2 plus n, right?
yes,
Both are the same thing, right?
yeah,
So here this 3 can be taken out and you can write it like this. R goes from 1 to k, R plus, notice what is this? 6 is being added how many times?
k times.
So it will be 6k,
Yes,
okay? And here what you have? R is going from 1 to k, right? So 1
yeah,
plus 2 plus 3 till k, right?
yeah,
Isn't that the value of this sum? R is going from 1 to k R, right?
yes.
What is the sum of this series?
K times k plus 1 over 2.
Right. And then you have to multiply it with 3. So you get 3k times k plus 1 over 2 plus 6k is equal to 750, right?
Yes,
Great. So now we are getting a quadratic equation. You should cancel 3 factor on everywhere, right?
yes,
You will get a 250 here and then multiply by 2. You will get k times k plus 1 plus 4k is equal to 500, right?
yes,
So we are getting a quadratic equation where the equation is k square plus 5k minus 500 is 0.
Yes.
Correct?
Yes.
What are the roots of this quadratic? You can easily say it is k plus 25 into k minus 20.
Oh, yes.
So answer will be k is equal to 20 because we don't want negative answers.
Yeah.
Is it clear what we have done?
Yes. Does K and all have to be integers?
Yeah, because that was not mentioned in the problem, but from the quadratic we are getting integers only, right?
But in order for you to use the sigma notation,
In order to use a sigma notation, the variable that is being sigmaed had to be in integer. There has to be an r, this has to be integer because the sigma notation means you are doing it that many times, right?
yeah.
You are counting ARs that many times. How many times? From 1 to n, right?
Yeah.
You can't do it if this is not an integer. Then you don't know where there are infinite
Yeah.
numbers between 1 and n, right?
Yes.
So this has to be an integer, but the other variables could be anything, right?
Yeah.
Only the r that is under the sigma, that has to be an integer.
Yeah.
Okay, find the sum. Find this sum. The question is sum r goes from 1 to 10. 4 plus 3r plus 2 to the power r minus 1.
Oh, I need to find that. Oh, oh, another geometric sequence. That's 2 plus 1 plus 2 plus 4 plus 6 plus 8 all the way to 2 to 9. So geometric sequence is a times 1 minus r to the n over 1 minus r, which is 1 times 1 minus 2 to the over 1 minus 2, which is being what? 1 minus 2 to 10 plus 1 minus 2 to 10 over 1 minus 2. Am I just supposed to find that? That's just equal to that's equal to 1 minus 2 to 10 over 1. So it's 204 plus 2 to the 10, to the 2 to the power of 10.
1024 plus 204, right?
Yeah.
Okay. So sigma notation, you are understanding what it is now, right?
Yeah.
Is recurrence relations, is that in the syllabus?
No, no.
I don't think that is.
Okay. So then I don't think there is anything left in sequences and series. All you have to do is practice a little bit. Try some more questions from your books, right?
Okay.
So technically, theory part is done. There is nothing else there. Okay.
Yeah.
We can try a few more questions, but majorly the topic is done. So the next thing that we can discuss, what is the second most annoying chapter? Tell me.
Say.
What is the worst? What is the weakest chapter? Either one of you.
One that I was also struggling on a bit was circular measure.
Circular measure. So basically the radians and all.
Yeah.
Okay, that is nothing. So that will take 5 minutes to discuss. There's nothing there. Um,
Oh.
So far in your normal situation, you have learned angles are 360 degrees, right? 0 to 360 degrees.
Yeah.
If this is your x-axis, this is y-axis. We can say this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. And we measure angles like this. And if a point goes from here and goes to here, this angle in the anti-clockwise way is known as plus theta. So basically the angle between Q, O and P, that angle is the positive angle. And if you go around the circle like this, clearly you can go from 0 to 360 almost, right?
Yeah.
The point P can end up anywhere. For example, it can end up here. And this angle would be the positive angle.
Yeah.
Basically, there is up to 90 degrees in the first quadrant, then up to 180 degrees in the second quadrant, then up to 270 degrees in the third quadrant, and then finally till 360 degrees in the fourth quadrant, right?
Yeah.
However, these angles are relying on the degree measure 0 to 360 degrees, where positive angles are measured in the anti-clockwise sense. Anti-clockwise angles are positive. If I had done the same thing, but instead of sending the point in an anti-clockwise way, I sent it in a clockwise way, sent it here, right?
Yeah.
This angle will be called minus 60, for example. Whenever you start from the positive x-axis and go clockwise, you will call it with a negative angle.
Okay.
Do you understand what I'm saying?
Yeah.
You should understand that minus 60 degree is the same as plus 300 degrees.
Okay.
Because you will end up at the same point if you go 300 degrees anti-clockwise, right?
Yeah.
60 degrees will be left, no, here.
Yeah.
So you should know that positive 270 degrees is how much? It is also same as minus 90,
Yes.
right?
Yes.
Positive 210 degrees is how much? Minus 150.
Yes.
The only difference is which side you are measuring angles from, anti-clockwise or clockwise, right?
Yeah.
Okay, now that is your old way of measuring angles, which are in degrees. Now we'll also introduce something called radians. Have they discussed this in class?
Yeah.
So I will tell you the reason for introducing the radian measure in a bit. But before that, we need to understand what is a radian. So if you take a circle of radius 1, and if you go some angles here and theta angle, and find out the length of this arc. Do you understand what I'm saying right now?
Yeah.
So you will realize that this angle is determined by the length of the arc and the radius of the circle. Okay?
Yeah.
You should imagine in your head, if the arc length is big, the angle will be big, no?
Yes, yes, yes.
So what you can do is calculate the ratio of arc length to radius.
Oh, yeah.
Calculate the ratio of arc length by radius. Okay.
Yeah.
If you calculate this ratio, people have defined this to be the angle in radians at the center.
Okay.
At the center of the circle.
Yeah.
So L by R is the definition of the angle at the center measured in the unit of radian.
Yeah.
Now, if you think about it, L by R is a ratio, right?
Yes.
And in the ratio, the numerator and the denominator both are of the same kind. Both of them are distances, right?
Yes.
So think about it. What will be the unit of L by R? The distance meter and meter will get cancelled, no?
Oh, yeah.
So L by R is going to be a pure number, no units, right?
Oh,
No units, pure number. Correct?
yeah.
So this theta, this angle theta is defined in terms of a radian which has no units. We can say angle is 2 radian. 2 radian is that angle where L by R ratio is 2.
Yeah.
Do you understand what I'm saying?
Yeah.
You will realize that that must be a quite a big angle. See?
Yeah.
Do you understand what I'm saying right now?
Yes.
The arc length has to be double of the radius, right?
Oh, yes.
Correct.
Yes.
Now think about it. We know that the total perimeter of a circle, circumference of a circle is 2 pi r, right?
Yes.
So
Oh,
suppose I took half of a circle, semicircle, right? What will be the perimeter of a semicircle?
pi on.
Pi r. So isn't that looking like an arc length, a big arc, pi r?
Yes.
So if you join the endpoints of the arc to the center, I should get the angle at the center right now.
Yes.
And how do I get this angle in radian units? I'll have to take the arc length divided by the radius, right?
Yes.
What is the arc length? Pi r
Yes.
divided by the radius. R gets cancelled, right?
Oh, yes.
So I'm getting pi radians, right? At the center.
Yes.
That is equal to the usual angle. You can see clearly this is 180 degrees in our usual meaning.
Yes.
So now we get the connection between radians and degrees. We know now that pi radians is equal to 180 degrees, right?
Yeah.
So 1 radian is how many degrees? 180 by pi. Correct?
Yeah. Yes.
180 by pi, the value of pi is 3.14 stuff. So when you calculate this, it will turn out that 1 radian is roughly 57 point something.
Oh, okay.
1 radian is around 57 degrees. The way to remember it is remember that pi radian will be 180.
Yeah.
So if you know pi radian is 180, then we can write every angle 90 degree as pi by 4, pi by 2, 360 degrees as 2 pi in radian, right?
Yes.
180 degrees is our pi radian. 45 degrees is pi by 4 radian. 60
Yeah.
degrees is pi by 3 radian, and so on, right?
Yeah.
And you can basically interconvert from degrees and radians, correct?
Yes.
Remember the definition of angle theta in radians. That angle is defined as the ratio of the arc length divided by the radius.
Yeah.
This is arc length on the circle, and small r is the radius of the circle. And in that case, the theta is the angle at the center.
Yes.
Do you understand what I'm saying?
Yeah.
The reason people use this, the reason radian will be used forever from now on in any higher maths, always the angle will be mentioned in radian. The reason is because when you do derivatives and all, you don't want to have angles in degrees. The formulas become really bad if you use angles in degrees.
Yeah.
So, for example, if I want to do sine x and I want to do derivative of this, right? Correct?
Yes.
So, if you write x in terms of degrees, then it will be super annoying. But if you write x in terms of radians, the answer is cos x.
Oh.
If you write x in terms of degrees, you will have a fraction pi by 180 in every formula.
Oh, yeah.
The conversion factor will be there in every formula, and people didn't want this to be there everywhere.
Yeah.
Because people didn't want these formulas to be ruined, they switched from degrees to radian. And radian, because it's a pure number, there is no ratio and all.
Yeah.
Because if you do degrees, then you will have to take into account what is the meaning of this unit, right?
Yes.
Then it will be annoying. It will be difficult to do calculus with degrees measured, right?
Yes.
So more details you will learn as you go slightly higher, but right now that is all that you need to know. The main application of all of this will come when you do a little bit of trigonometry and see what is being taught there.
Yes.
So if they have already finished trigonometry, you should start looking at the questions in trig and see whether you are able to solve or not, which identities you are able to understand, and if there is any problem anywhere.
Yeah.
Okay, what is the next thing? This is not a big enough topic. You need to tell me what is the major thing that you are not comfortable with, anything that is a problem. Coordinate geometry, how is it?
Coordinate geometry.
Are you
A
understanding
bit
what
of,
is happening?
I don't really like. I'm not the best, but like the circles in coordinate geometry, like that.
I didn't get what you're saying. What are you saying?
Like the circle part in
Mhm.
coordinate geometry.
Hmm.
That part I still don't really know.
Hmm. Circle part you know or you don't know?
Don't know.
What about straight lines and stuff?
Straight lines, I know.
You know the slopes and everything, what it means and all, right?
Yeah. Yeah.
Do you know what is distance formula? How to
Yes.
find the distance between any 2 points?
Yes.
How? Tell me.
So you take the square root of x1 plus x2.
No.
Wait, no, wait. Oh, wait. It's the square root of x1. Oh, yes, that's it.
Why is it like that?
Because it's sort of like Pythagoras theorem. So you just have like a triangle and you take the two side lengths squared.
It is not sort of, it is exactly Pythagoras theorem. This is P, this is Q. Then you can join it and make it like this and join it like this, right?
Yes.
What is this distance? x2 minus x1.
Yeah.
What is this distance?
y2 minus.
So obviously this will be, hypotenuse will be y2 minus y1 squared plus x2 minus x1 squared under root.
Yes.
Now, do you know the concept of locus?
No.
Noah, do you know what is a locus?
Yes. So the locus is like if you have it's like it's just like the path that the point follows.
As long as it satisfies some conditions, right?
Yeah, so it's a way of like expressing certain equation.
So, for example, if I ask you, what is the locus of a point P that is equidistant from two given points? How would you answer that? So for Adam, what a locus means is, suppose there is some information given, like in this question, I'm saying 2 points are given, right?
Yeah.
Now the question is asking what is the locus of a point that is equidistant from the 2 given points, right?
Yes.
So in general, our variable point can be anywhere in space, right?
Yes.
In general, our variable point could be anywhere here, could be here, could be here, could be here. But it is not free to be anywhere because according to the question, it has to be equidistant from A and B, right?
Yes.
So this point will not be allowed. No, this is not a null locus
No.
because it is not satisfying the condition that the point P is equidistant from A and B.
Oh, yes. Yeah.
So we need only those points which satisfy the conditions of the problem, right?
Yes.
And all those points will lie on some sort of a locus, and the locus will be the curve or the path made by those points. Which points? The points which satisfy the conditions.
Yes.
In this case, our condition is the distance of P to A is same as the distance of P to B, right?
Yes.
So can you think of any one point where P can be?
The midpoint?
Right, so that is obvious that obviously P can be on the midpoint, right?
Yes.
What about any other point? What other points can you find where P is always equidistant from A and B?
Well, any point on that perpendicular line.
Right. So any point on the perpendicular bisector, if P is anywhere here, by congruent triangles, you can say that because this is equal to this and this is 90 and 90 and this side is common, these two triangles are congruent and therefore PA will be equal to PB.
Yes.
So in our question, the locus of P such that P is equidistant from A and B, which are two given points, from two given points A and B, will be, what is the locus? Locus is line perpendicular bisector of segment AB.
Yeah.
So P can be anywhere on this line, right?
Yeah.
That is my locus. Is it clear?
Yes.
Now, a simple question would be find the locus of P when PA by PB is equal to K is not equal to 1, and K is a constant. K is a constant where A and B are fixed points. Think about this for a moment, both of you. If K was equal to 1, we just now did the locus, right?
Yes.
Yeah.
We want PA by PB to be equal to a fixed ratio, but the value K is not 1.
Yeah.
It can be any K, but it's not 1. That's it.
So
And we can say it is non-zero. Let's say it is non-zero positive. Non-zero positive, but not 1. And we want to find the locus of P.
will not be any point that's not on the perpendicular bisector of AB.
No, but how will K ratio remain fixed then?
Oh, it will be any point, any perpendicular bisector, but not on the midpoint.
No. See, what you are saying
Oh,
is the ratio has to be always same, no?
yeah,
Suppose you put points on an altitude like this, but not on the midpoint. That's what you said, right?
yeah.
If P is here and P is here, do you think the ratio of PA and PP is same?
Oh,
This PA by PB is not the same as this PA by PB, right?
yeah,
It
yeah.
is not, P cannot be on a straight line. It doesn't look like it is, at least this line. A and B are fixed, and you need to ensure that PA by PB is always fixed, right?
So it will be the middle of A and B,
Yeah.
What do you mean middle of N?
where PA will be equal to PB.
But
This K is not necessary to be 1. It is not equal to 1. They have been mentioned. That has been given.
Yes.
If K was equal to 1, then what you are saying is correct. And we have already done that case. No, it is perpendicular bisector in that case.
Yes. But then uh,
For example, right now, forget about K. Just find the locus when it is 1 by 3.
oh, okay.
I am putting a value of K. K is 1 by 3. We need to figure out the locus of P.
it'll be here.
Okay, so you should think about it yourself. There is a pure geometry way of figuring it out, and that I will leave to you for now. The locus will be P lies on a circle. Okay, so
Yes.
why is that? Because if AB is fixed, think about it. This is angle on a circle.
Oh,
Like PA by PB is always same. So if you think of these two triangles, right now it doesn't look same. 1 second. Okay, one way to do it easily is like this. PA by PB is 1 by 3. Let's say P is x comma y, right? And let's label A as 0 comma 0 and let's label B as B comma 0. Do you understand what I'm saying?
yes,
We are calling A as the origin and we are calling B as a point B comma 0. And P is a variable point, right?
yes,
So P can be anywhere in space. Let's use our distance formula. Let's use our distance formula. What is PA distance? Tell me.
it's x is the square root of x squared plus y squared.
Divided by PB distance is what?
The square root of x minus b squared plus y squared.
So can you see this equation?
Yes,
You'll get x squared plus y squared by x minus b whole square plus y squared is equal to 1 over 9, right?
yes,
9x squared plus 9y squared is equal to x minus b whole square plus y squared. And now simplify everything. You will get 8x squared plus 8y squared and you will get plus 16bx and minus b squared equals 0.
yeah,
And now divide by 8, you'll get x squared plus y squared plus 2bx minus b squared by 8 is equal to 0, right?
yeah,
This equation represents a circle. For example,
yeah,
you can easily find the center and radius of that circle if you've studied circles chapter. By completing the square, we can find center and radius. See, I will complete the square here. So I'll say x squared plus 2bx plus b squared minus b squared because I've added this, right? Plus y squared minus b squared by 8 is 0. Do you understand what I'm doing? X plus b
yeah,
whole square plus y squared minus 9b squared by 8 is 0, right?
yes,
X plus b whole square plus y square is equal to 9b squared by 8. So
Yeah.
clearly this is a circle with center minus b comma 0 and radius of 3b by 2 root 2.
yeah,
Do you understand what I'm getting right now?
yes,
So what we have figured out is when PA by PB is equal to K, where K is not equal to 1, I'm getting P lies on a circle. But there is a geometry proof of it, which I will leave for you right now. If you don't get it, we can discuss it in a future class. What we have
okay,
done right now, the geometry proof is slightly difficult to figure out. So it is therefore given as homework. What we have done right now is that we have seen the power of coordinate geometry because without doing any geometry, we were able to get the equation and know that it is a circle.
yeah,
Without much thinking, just by doing little bit of algebra, I was able to figure out the circle, figure out the center, figure out the radius.
Yeah.
That you cannot do so easily using geometry. You'll have to think a lot to figure all that out by just pure geometry.
Yeah.
So that is why we use coordinate geometry. That is the power of the method. I just wanted to show you a way in which a locus comes as a circle. The standard way to define a circle is locus of points P, which are equidistant from a known point, right?
Oh.
What is a given point? This given point becomes your center.
Yes.
And what is the distance? Distance is your radius.
Yes.
Look, this is the normal way to define a circle. Locus of points P, which are such that they are always equidistant from a given point, right?
Yeah. Yes.
What you will do is take the point P as x comma y, and let's say the given point is x naught, y naught. Then the distance between this and this is always fixed. So you'll say root over x minus x naught whole square plus y minus y naught whole square is always fixed, and it is radius, right?
Yes.
So when you expand it, you will say x minus x naught whole square plus y minus y naught whole square is equal to r square, right?
Yes.
And that is your standard circle equation. Center becomes x naught, y naught, radius becomes r, right?
Yes.
But notice that that's not the only way to define a circle. We just saw a different way to define a circle.
We did.
Did we just not see the different way to get a locus of a circle?
Oh, yes. 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 Yes.
We said locus of point P such that PA by PB is a constant not equal to 1.
Yeah.
And that point P always was lying on a circle. We got an equation like this only, no? We
Yes.
got x plus b whole square plus y square is equal to 9b square by 8, right?
Yes.
That is clearly a circle equation.
Yes.
So what I'm saying is there are many ways to get circles. One way was the standard way is to define a circle in this way. One way we saw, another way was this. But you have to study the chapter carefully and see the algebra of it, understand the algebraic methods that are being taught first, and try out a few problems, and then you will understand the intricacies involved. There are a lot of things to learn in circles. We are barely scratching the surface right now. But
Yeah.
what you have to do is like look through the chapter, what they are teaching. The stuff in your school, it will only be equations of circles and finding out how lines intersect circles and how lines will become tangent to circles and things like that. So all that is not very difficult, but try it out, and if you keep getting stuck or something, we can discuss it in the next class.
Okay.
Tomorrow afternoon, there will be classes for the Olympiad stuff. For A levels, if you need more help, we can do a class next week sometime. Okay.
Okay.
So do your revision for your school curriculum, your A level exams, and find out things that you're struggling with. Whenever you need a class, you can tell me and we can finish it off, whatever is bothering you. But
Yeah.
the normal Olympiad classes will continue as usual. So tomorrow there will be classes in the afternoon for that. Okay.
Okay.
Okay, fine. That's all for now then.
Thank you.
Bye.